Hello students. So till now we have basically learned what was classification, and in specific we saw what is rule-based classification, classification by Bayesian belief network, and HMM, that is hidden Markov model. After that we also saw what is SVM, supervised support vector machine. And we saw how support vector machine is used for classification problem, which comes under the category of supervised machine learning technique. In today's session, we are going to focus on what is clustering. So let's see what do you mean by clustering. So before understanding what is clustering, it is essential to know what do you mean by a cluster. A cluster is a collection of data points or data objects. Now these data points or objects may be similar or dissimilar, or related or unrelated. So similar data objects are the one where all the similar points are placed in the same group, whereas dissimilar data objects or unrelated data objects are those which are placed in different groups or different clusters. Now, how do you find or analyze these clusters? It is basically by determining similarities between the data according to the characteristics that are found in the data and grouping all these similar data objects or data points into a common cluster. So in simple terms, when you are grouping data objects or data points on the basis of their similarity into different groups, this process is called as clustering, and these individual groups are termed to be clusters. Clustering is basically used for unsupervised learning. Unsupervised learning, as we all know, means there is no labeling, no predefined classes. That is, learning takes place in unsupervised learning through observations. What are the typical applications of cluster analysis? As a standalone tool to get insightful information about distribution of the data, we use clustering, and it is also used as a pre-processing step for other algorithms. Now let us see the applications of clustering. First point, it is used for information retrieval. Now when we have got documents of similar type or kind, and when they are placed together, from there insightful information can be retrieved. So there clustering is used. The second application is land use. Identification of areas of similar land use in an Earth observation database. Clustering is also helpful in marketing. It helps marketers discover distinct groups in their customer databases and then use this knowledge to develop targeted marketing programs. Planning of the city is also using clustering. It identifies the groups of houses according to their house type, value, and geographical location. Studying earthquake, that is observing the areas where earthquake is the epicenter, and all these should be clustered along continent faults. understanding the climatic conditions of the earth, finding patterns of atmosphere and the pattern that is followed by the oceans. These are some of the applications where clustering is used, and through clustering people try to understand the data. Now clustering, when we are talking as a pre-processing tool or a utility tool, it is used for the following purposes. Summarization. So basically if we want to perform text summarization, document summarization, then clustering plays a major role. For regression also, one of the pre-processing steps followed is clustering. It is used for PCA, principal component analysis. We will take this topic in the upcoming sessions. It is used for classification and association. In image processing, also clustering plays a very important role for compressing the images, which is nothing but vector quantization. Then there is a technique which is used for performing clustering, which is nothing but the famous algorithm KNN algorithm, K nearest neighbor. In this algorithm, we localize the search to one or a small number of clusters. So data points belonging to their similarity are placed in a particular cluster. So a particular format is followed in the algorithm KNN. Another important aspect of clustering as a pre-processing tool is detecting outliers. Outliers are often viewed as those far away from any cluster. Let me take an example to explain y'all what is an outlier. Basically, if I'm considering this graph, I've generated this particular plot using the Seaborn library in Python. Now there was a data set, and in this data set I have basically tried to identify the data points which are belonging to a common functionality to be placed in a single group or a cluster. So here if you observe, what is happening is the data points which are not actually falling to that common cluster, they are called as outliers. So if you observe over here, if I'm considering this portion to be one cluster, you can see there are some data points which are dispersed, and these data points may be not suitable for that cluster, and that is why they are called as outliers. So outliers are often viewed as those far away from any cluster. So if you're considering this to be a cluster, you can see these are outliers because these are lying far away from the cluster. Now, what is a good clustering? A good clustering will produce high quality clusters, which is nothing but clustering is based on similarity. So we have got high intra-class similarity and low inter-class similarity. Intra-class similarity is nothing but cohesive within clusters. That is, sticking to the defined cluster is high intra-class similarity. Low inter-class similarity is nothing but distinctive. We can clearly differentiate between two clusters. That is your low interclass similarity. The quality of clustering method depends upon these three important parameters: the measure of similarity, how you are implementing the clustering, and ability to discover some of the hidden patterns or all the hidden patterns. Out of these three, similarity measure is very important quality to identify whether a cluster is a good or a bad cluster. Now, these are some of the measures that can be used for identifying the quality of clustering. So we have got a similarity or dissimilarity matrix, quality of clustering. So similarity is always expressed in terms of a distance function, which is nothing but d of I and j. So you will be having a data point which is lying an intersection of I and j value in a graph. So from there we can find out the distance measure and calculate the similarity. The definitions of distance function are different for interval scaled, Boolean, categorical, ordinal and vector variables. Weights should be associated with these variables based on applications and data semantics. So there is no specific way of saying whether a cluster is good or bad. It totally depends upon the similarity measure, which helps us to identify the goodness of a cluster. So it is hard to define similar enough or good enough cluster. So the answer whether a cluster is good or it is less efficient is totally subjective. These are some of the requirements and challenges that are faced in clustering. Scalability is an issue. Ability to deal with different types of attributes. Now, attributes in a dataset can be numerical, binary, categorical, ordinal, etc. So, it becomes difficult to apply clustering. So, we will have to pre-process this particular dataset. Constraint based clustering. User may give inputs on constraints. Use domain knowledge to determine input parameters. Interpretability would be one of the challenge, and using usability is another issue. The others are discovery of clusters with arbitrary shape, a random shape which doesn't give us any intuition or inference, ability to deal with noisy data, that is the outliers, incremental clustering and insensitivity to input order, and high dimensionality are some of the requirements and challenges that are faced by clustering. Types of clustering, we have got hard clustering and soft clustering. So clusters that do not overlap fall under the category of hard clustering. See over here, elements either belong to cluster, a specific cluster, or they do not. And soft clustering is nothing but the clusters overlap. So the strength of association between clusters and the instances, they represent your soft clustering. Thank you.